Graph the function f of x equals 1 over x plus 1. This is a rational function. In order to graph a rational function, we should first find the vertical asymptotes. We do this by setting the denominator equal to 0. So we will set x plus 1 equal to 0. When we solve for x, we find that the vertical asymptote will be the vertical line x equals negative 1. So we will graph the vertical line x equals negative 1 with a dashed line to indicate the location of the vertical asymptote. Next, we should find the horizontal asymptote if one exists. We can use this table to help us determine what the value of the horizontal asymptote is if it exists. If the numerator degree is less than the denominator degree, then the horizontal asymptote will be the horizontal line y equals 0. We note that the degree of the numerator is equal to 0 since it is a constant. The degree of the denominator is 1 since it is linear. Since the numerator degree is less than the denominator degree, the horizontal asymptote will be the horizontal line y equals 0. So we will graph the horizontal line y equals 0 with a dashed line to indicate the location of the horizontal asymptote. Next, we will need to determine if and where the graph crosses the horizontal asymptote by setting the function equal to the value of the horizontal asymptote. The horizontal asymptote this time is the line y equals 0. So we will set the entire function equal to 0. We can begin to solve for x by multiplying both sides by x plus 1 in order to clear the fraction. When we do this, we wind up with an equation 0 equals 1. But 0 is not equal to 1. So this indicates to us that there is no value that we could substitute for x that would result in a value of 0 for this function. So therefore, the graph does not cross the horizontal asymptote. Now we will plot some points. It will be interesting to see what is happening on either side of the vertical asymptote. So we will substitute values that are less than negative 1 for x, such as negative 4. F of negative 4 would be equal to negative 1/3. So when x is negative 4, y will be negative 1/3. So we will plot the point negative 4, negative 1/3. F of negative 3 will be equal to negative 1/2. So we will plot the point negative 3, negative 1/2. F of negative 2 is equal to negative 1. So we will plot the point negative 2, negative 1. F of negative 3/2 is equal to negative 2. So we will plot the point negative 3/2, negative 2. We can see a trend happening in this curve. We know that the graph must approach but never actually touch the asymptotes. So we can graph then this function by drawing a curve through these dots that satisfies that condition that we should infinitely approach the asymptotes but never actually reach them. Now let's do the same thing for values that are greater than negative 1. F of 0 will be equal to 1, so we will plot the point 0, 1. F of 1 will be equal to 1/2, so we will plot the point 1, 1/2. F of 2 is equal to 1/3, so we will plot the point 2, 1/3. Now we see the same trends on the right side of the vertical asymptote. The graph should infinitely approach the asymptotes, but never actually reach them.